This is the buffer problem set 3A. So 3 is very similar to problem 2, except the difference is we're adding base. So we're adding 0.020 moles of NaOH, which I know is really just adding OH minus, that's the important part, in 1 liter of solution. So this means that I'm really adding 0.02 molar OH minus to the solution. So just like I did in problem 2, I know that when I react this with an acid, it's going to be a chemical reaction. However, if I react it with a base, it's going to establish some equilibrium. So let's take a look at this. If I add this to part 1A, which comes side down here, well, 1A, I have 0.1 molar propanoic acid. So if I have propanoic acid, HC3H5O2, and I add OH to it, OH minus, it is going to react. So I'm drawing an arrow one direction. This is not an equilibrium reaction, it's actually reacting. And I will make water because it's an acid base. This H plus goes with this OH minus, and then I'm left over with C3H5O2, the propanoate ion. So when I look at this, I know it's not really an equilibrium so much as my end point of my reaction. So I did start with 0.1 molar. How much OH? I have 0.02 molar. I get that from how much I added. I didn't start with any water, and it really doesn't matter because it's a liquid. And I didn't start with any of my propanoate. So when I look at this, the change, it's not X's here. I'm using my buffer problem assumption, which is that all the OH will get used up. So I'm going to use up 0.02. And what that's going to leave me with is somewhere around 0. And that means I'm also going to use up 0.02. And then I'm going to make 0.02 over here. So when I do the math, I get 0.08 and 0.02. These numbers should look very familiar to you. They're very similar to problem number 2. So now I'm going to look at these two ending numbers. And I know these two ending numbers are going to establish some equilibrium because I have propanoic acid and propanoate. So when I look at this, HC3H5O2 in water is in equilibrium with H3O plus and C3H5O2 minus. So what this means is I'm going to make an equilibrium icebox. I have 0.08 molar propanoic acid because that's what I ended with after my chemical reaction. Don't worry about the water. I don't have any H3O plus, and I have 0.02 molar propanoate because that's what I ended with in my chemical reaction. Now, I'm assuming it has to go to the right because I don't have any H3O plus to react. So when I do that, I'm going to have minus X plus X plus X, 0.08 minus X, X, and 0.02 plus X. And I'm going to write my Ka for that, which I know from problem number 1 still is 1.3 times 10 to the negative 5th. I'm using a Ka because I'm dealing with the acid. If I had written this the other way and I was dealing with the base, then I would definitely have flipped this around. So when I look at this, I'm going to have the products, X times 0.02 plus X, divided by the reactants, 0.08 minus X. And again, I can ignore the X's. So what I really have is 0.02 times X divided by 0.08, and that equals the Ka. So get out your calculator. We're going to solve for X. So 1.3 times 10 to the negative 5th. And you're going to multiply that by 0.08 and then divide by 0.02. And you get, hopefully, the same answer I did, 5.2 times 10 to the negative 5th. Now, if I look at that, that happens to also be the concentration of H3O plus. So when I'm doing my calculations, I can say the pH is the negative log of that number. So when I plug that in my calculator, why don't you do that now? I get 4.28 is the pH.